Hi, everyone. My name is Austin Quach, co-founder of Dalton Bioanalytics. We are digitizing blood for the future of human health. These are the biomarkers that make up our annual blood work. There are small molecules like glucose, electrolytes like calcium, proteins like hemoglobin, and lipids like cholesterol. For the past 40 years, these same 32 biomarkers have been used in our routine checkups. Even with all the tests that doctors can order, they're only looking at about 1,000 biomarkers, leaving more than 4,000 blood biochemicals unexamined. The complete view of all of these molecules, known as multiomics, has been shown to dramatically improve diagnostic performance across a wide range of diseases. Researchers, liquid biopsy companies, and innovative healthcare systems alike are sprinting towards using multiomics for early detection and ultimately better patient outcomes. Unfortunately, it's still a huge pain to run this analysis. You have to split your samples, send them to several specialized laboratories, have a bioinformatics expert integrate the data at the risk of distorting the results. In total, this can cost thousands of dollars per sample. Dalton is a one-stop shop. We measure proteins, lipids, electrolytes, metabolites, and other small molecules for just $500 per sample, dramatically simplifying this entire process. We can do this because we've invented a new way of using tried and true mass spectrometry to measure all types of biochemicals in a single run. We take the macromolecules and we clip them up into smaller pieces. We take the misbehaving molecules and we pair them with chemical chaperones. We digitize this entire complex mixture using high-resolution LC-MS, and we reassemble the sample in the computer using bioinformatic algorithms. We've automated this entire process from sample preparation to data analysis and acquisition. The only thing we do manually is move the sample plate from machine to machine. This is a spectrogram showing our analysis of human plasma. Each of the colored specks here represents a unique molecular feature that we find in blood. For example, in the bottom left-hand corner, zooming in more than 1,000x to this specific mass and time, we see the signal for glucose. Over here on the right, at this specific mass and time, is the signal for one of the forms of triglycerides. The center cloud is composed of fragments from over 700 proteins. The dense cloud to the right is composed of hundreds of lipids, and sprinkled along the bottom and left are electrolytes and small molecules. In total, after optimization, we expect to be able to measure more than 2,000 blood biochemicals in a single run. Our method has high reproducibility, with global correlations between repeat measurements greater than 95%. At our time in IndieBio, we've gone on to demonstrate an important proof of concept. Using machine learning, our data can be used to learn new biomarker signatures, getting smarter with every run. Traditional diagnoses are based on just a few biomarkers. Here, highlighted by these boxes in yellow, are all of the analytes we found are associated with aging, cardiovascular disease, inflammation, and dementia. Remember, these aren't separate assays. We can run all of these and more using just one single blood analysis. And every new biomarker we identify holds enormous research potential into its hidden role in disease. This is the value we provide to our customers in the rapidly growing multiomics market. Since our time at IndieBio, our machine has been running nearly 24/7. We have 2 ongoing clinical pilot studies and 2 letters of intent reserving future instrument time. But it's not just the LOIs. We're helping to answer questions such as, can we diagnose kidney transplant rejection before it happens? Congenital heart disease before birth. For those of you with allergies, Can we replace steroids with a natural, non-toxic compound? Can we diagnose Lyme disease accurately? We're not just another diagnostics company developing a one-off test. We're partnering with researchers, empowering them to replace existing tests with superior biomarker signatures, and more importantly, to discover brand new tests to address the numerous unmet diagnostic needs that are struggling to be fulfilled. Drawing upon data that we gather from our multi-omic research platform, we'll continue to develop new clinical tests that will expand the existing clinical lab market. We see ourselves much like next-generation sequencing, a complete scan for numerous diseases and conditions. However, unlike NGS, we'll be able to create a low-cost liquid biopsy for rare and common diseases. Long-term, this means that we can readily integrate into existing healthcare practices as a semi-annual blood test. I co-invented this method during my PhD at UCLA, where we demonstrated for the first time in history that we can measure all types of biochemicals using a single assay. Seung-Jun Yeo, our CEO, brings his leadership and experience from his previous venture, developing AI software for prenatal detection of congenital heart disease. Our advisors are composed of world-class experts in analytical chemistry, molecular diagnostics, and medicine. Dr. Kim Fall is co-inventor of the method. He offered us invaluable resources and guidance during the development of the assay. Richard and Yalda continue to shape how we will develop new clinical tests that meet the rigorous standards expected by the medical community. We have full protection of our technology stack with exclusive licensing of the analytical method from UCLA and development of the bioinformatic algorithms in-house at Dalton. We're raising our seed round to build our lab, launch our multi-omic research service, and then we'll get certified as a CLIA lab to run clinical tests for medical providers. We're raising $3.2 million to build our lab. Please come find us to learn how the future of medicine is fueled by digitized blood. Thank you.